Hello again. I've managed to reclaim the back room of this coffee shop. Um, so back to the document camera. It might not be very high tech, but for ease of use, well, you saw me use the touch screen and it wasn't great. In this video, I'm just going to present the idea of a tangent line, which is intimately related to the idea of the instantaneous rate of change. So, the average rate of change, f of b minus f of a over b minus a. You have an interval from a to b. You have a function doing whatever the function is doing. And you have the average rate of change on the interval. And this average rate of change formula is the slope of a line. If we start at the point a comma f of a and end at the point b comma f of b, the average rate of change is the slope of the line connecting those points. And we call this line a secant line. Now, this is just average rate of change, no limits involved. But what happens if you go from the average rate of change on an interval to the instantaneous rate of change at A? What happens if you let B get closer and closer to A? Well, every time B moves, you get a new little interval and a new average rate of change and a new secant line. So as B approaches A, this quotient is approaching a number, right? This quotient is approaching the instantaneous rate of change at A. Meanwhile, as B approaches A, these secant lines are also approaching something. I mean, what can they be approaching? Well, they're approaching a line. These numbers approach a number. These lines approach a line. Something like my artistic skill is not my greatest strength, but in the picture, they're approaching a line something like this. As B gets closer and closer to A, these secant lines are getting closer and closer to that line that I drew here. And this line is called the tangent line. And tangent lines are one of those things that in calculus classes, I mean, including this one, they get presented and they occasionally show up in homework or quizzes, but they sort of drop out of everyday use pretty quickly. But tangent lines are really, really important in a lot of physical applications because tangent lines give the direction of a curve. Like, imagine that a curve is a road. You are physically traversing a curve. And because the road is always curved, you are always adjusting the steering wheel. So suppose you're going along and you're going along and you're going along, and suddenly your steering mechanism locks up and you stop being able to turn. What will happen? Well, if you can't turn, you can only go straight. So you will go straight until you go off the road. In particular, you'll go in a straight line that looks something like that. And that straight line is specifically the tangent line at this point where we lose control. So tangent lines show up a lot in engineering applications or mechanical applications or any application where you care about the direction of the curve. We may not talk about them every day in an applied calculus class, but they really are a significant application. And with that remark, I will see you next video.